Welcome back. So, yesterday we talked about how to make a line of best fit and how to represent or how to interpret all of the different pieces, the slope, y-intercept, all of those types of things. Today we're going to dive into the fact that the line doesn't pass through every single point, okay? So there's a concept called the residual, okay? So the residual is the difference between the observed value and the predicted value, okay? So the residual gets this equation. And you do have to have that memorized, okay? The residual is observed minus predicted, okay? And so what the line of best fit is, or the least squares regression line, what that is a line that minimizes those residuals, okay? That makes those residuals as small as possible for all of the points, okay? So let's take a look at this. So below is some data on the relation between the price of a certain manufacturer's flat panel LCD television and the area of the screen. We like to use the data to predict the price of televisions based on the size. Now here the nice thing is, they actually provided us with the equation. So the predicted price is 105.74 plus 0.77 times the area. All right, so find the predicted price. Well, the predicted price for a 437 square inch TV is just going to be 105 plus 74 plus 0.77 times that area. So 105.74 plus 0.77 times 437. So the predicted price is going to be that much, okay? We're predicting it's going to cost about $442.23 based on our equation. Now, what the residual is the residual calculates how different is that from the actual data point, okay? And the residual is observed minus predicted. Now, how could we possibly know what the observed value is? Well, this value is actually right out of the table. Okay, so we actually do have an observed value for this, $375, but we predicted 442.23. So 375 minus 442.23. So the residual is negative $67.23. Now, what does this mean though? Okay, what is it telling us? Well, what it's telling us is that the predicted value is much higher than the observed. Okay, because if you think about how is a residual negative, the residual is negative if the predicted is more, right? So what is it saying? What it's saying is for a 437 square inch TV, our line, or our prediction, or our least squares regression line over predicted by $67.23. Because that's how you get a negative residual. It's if your prediction is more, if you over predicted. Okay, so that's how you find residual, observed minus predicted. And then you will also have to be able to interpret what it means. What it means is for that TV, we overpredicted by $67.23. So what about the residual for the TV with screen size 683? So same thing, let's go through. We need to use our prediction line to find the predicted value. So our predicted price is going to be 105.74 plus 0.77, 683, and just plug that into the calculator. 105.74 plus 0.77 times 683. And we are getting $631.65. The residual, again, is the actual value, the observed, minus our predicted value. So let's go back to that table again and find actual value is $650. So we have the actual 650 minus 631.65, and that is going to be $18.35. All right, and what does this mean? Well, for it to be a positive residual means that the observed price is more. So this time our prediction was less. We underpredicted our value. Okay? So, underprediction looks, or to describe that, so we're going to say for a 683 square inch TV, our equation underpredicted the cost by $18.35. Okay, that's how we would note the residual in this case. What about the slope? Okay, so let's not forget what we did yesterday. So our slope is 0.77. Okay, so what does that mean? Well, as x increases by 1, so for every increase of 1 square inch in area, it's saying the y increases, so the predicted price increases by 77 cents. Okay, so for every increase of 1 square inch, the price goes up by, excuse me, by 77 cents. And what about the correlation coefficient? Okay, R is 0.98. We've seen the scatter plot. We can tell that it looks linear. So what does it mean? It means there is a strong, because it's almost 1, positive, because it's a positive value, linear relationship between area and price, the area of the TV screen and the price. All right, now there actually is another way to calculate the area, or not area, sorry, calculate the least squares regression line, okay? So you can calculate the slope and the y-intercept based on the mean values and the standard deviation of those values, okay? Now, the neat thing is, and I can show you this, these are on your formula sheet that you get to use on my tests, okay? So I'm going to show you to make sure that you're very comfortable using that formula sheet on the test because it is definitely going to help you. But essentially, this is going to be a second way to calculate a least squares regression line. If you don't have the data, if all you have are the means of standard deviations, well, you can still calculate it, okay? So let me step you through that process. Some people think that the behavior of the stock market in January predicts its behavior for the rest of the year. Take the explanatory variable X to be the percentage change of the stock market in January, and the response to be the change in the entire year. We would expect to find a positive correlation between X and Y because the change during January contributes to the full year's change. Calculate the data for an 18-year period gives that. They wanted to find the equation of the least squares regression line. All right, so here I give you a little hint. So they give us the mean and standard deviation and R. And they wanted to calculate the equation. So I would always start with slope. Okay, and if you flip back, it says the slope is R, which is 0.596 times standard deviation of y, which is 15.35, divided by the standard deviation of x, 5.36. Okay, so it just gives you a formula to calculate r that you just have to know how to plug it into. Okay, so 0.596 times 15.35 divided by 5.36. And that is roughly going to give you 1.71 for your slope. All right. Now, from that, you can go and find the y-intercept. Okay, so the y-intercept, its formula says, take the average or the mean of y minus b, which is your slope, so minus that slope you just calculated, times the average of x. All right, so really, it's just plugging into a formula. So 9.07 minus 1.71 times 1.75 gives you about 6.08. So our formula would look like this. All right. So again, it's not too hard as long as you know the formulas to use. It's completely doable. Okay. So now let's take a look at this. So the mean change in January is 1.75%. Use the regression line to predict the change of the index in a year where it rises by that 1.5% in January. So basically it's saying predict the year change if January really does rise from that mean. Okay? So I plug that 1.75 into my calculator. So 1.71 times 1.75 plus 6.08. And it gives me a change of 9.07%. Now, that should strike you as interesting because look at what that's telling us. What it's telling us is the point x mean, y mean is actually on our regression line. And that is actually true for every single regression line. Okay? The mean of x and the mean of y are actually always a point on your graph, okay, which I think is really kind of interesting and really cool. All right, so I believe that is all for our notes today. So once again, as always, thank you for joining me for this, and please make sure you ask me any questions if there's anything that you need cleared up.